story of nuclear weapons will have one of two endings. It will be the end of nuclear weapons, or it will be the end of us. For deterrence to work, the other party has to assume that we're willing to kill ourselves. And so that doesn't make any sense. That means we're acting like a suicide bomber. There have been many war games between India and Pakistan, and they give a scenario. So they use one weapon to stop you. What would you do? And it always escalates to using the entire arsenal. There's no such thing as a limit to nuclear war.
Welcome to Saving the World from Bad Ideas. I'm Mark Lynas, and I've had a few bad ideas in my time. I used to go out in the nighttime to destroy GMO crops, and I also opposed nuclear power. But then when I looked at the science, I found I got it wrong. Oops! I've learned the hard way that none of us are right all the time. So now I'm here to challenge the assumptions that we all too often take for granted, because the future depends on us getting it right. Our guest today is someone who's dedicated his life to understanding the climate system and what happens when humanity interferes with it in the most extreme and catastrophic ways. Alan Robock is a distinguished professor of environmental sciences at Rutgers University, a leading authority on climate modelling and one of the world's foremost experts on nuclear winter, which is an issue of extreme interest to me. His research has shaped international understanding of how a nuclear exchange, even a limited one, could trigger catastrophic global cooling, threatening food systems and even a breakdown in human civilization. More recently, he's been a central voice in the fraught debate about solar geoengineering, which we've covered already in a couple of podcast episodes. And he's often to be found warning that the cure could be as dangerous as the disease. Now, I can't wait to get into all of this. So, Alan Robock, you're very welcome.
Thanks for your interest.
Now, our format, as you know, is bad ideas, saving the world from bad ideas. And we discussed this a bit, and we thought that the bad idea that you could be saving the world from is that we need nuclear weapons to prevent major wars, let's say, because that's a pretty pervasive, if you speak to people about nuclear weapons, a lot of people will come back to me at least saying this, that, that nuclear weapons, the existence of nuclear weapons and perhaps deterrence has prevented at least superpower wars for the last 80 years, since 1945. I mean, what do you say to that?
Yes, deterrence is the religion that they subscribe to argue that we need nuclear weapons. The problem is the theory of deterrence is faulty. The theory is we will attack you if you attack us. We will try to deter your attack, and if you attack us, we will attack you back, and that's called mutual assured destruction. The problem is, if we use our nuclear weapons to attack, say, Russia, we'll all die from the resulting impacts on climate and food and agriculture. So if we're threatening to use our nuclear weapons, that means we're acting like a suicide bomber. For deterrence to work, the other party has to assume that we're willing to kill ourselves. And so that doesn't make any sense. And so the problem is that the existence of nuclear weapons means that they can be used. And since the first nuclear war 80 years ago, as you mentioned, we've come very close several times. And it's only by luck that we've not had another nuclear war. So that's the problem. The deterrence does not work in deterring attacks by non-nuclear nations, by cyber terrorists, by extremists. There are many examples that nuclear nations have been attacked by non-nuclear nations, and their nuclear arsenal didn't deter anybody. For example, most recently, Hamas attacked Israel. Even more recently than that, Ukraine attacked Russia. Ukraine invaded an edge of Russia, and their nuclear weapons didn't deter the attack. In the past, Israel was attacked during the 6 Days War. The Falkland Islands were attacked by Argentina. UK has nuclear weapons. And so when there was only one nuclear power, the United States, Eastern Europe was invaded by the Soviet Union, and our nuclear arsenal didn't deter them. And so clearly nuclear weapons, that a terrorist attacked New York City in 2001, our nuclear arsenal didn't deter them. So clearly nuclear weapons don't act as a deterrent. against non-nuclear nations. They say, "Oh no, that's not what we meant. We meant that they deter attacks from other nuclear nations." And it's true, there haven't been wars between nuclear nations, but why? Is it deterrence or is it something else? There's many other possible theories.
Yeah, I mean, I guess also the the deterrence picture is reversed if you consider that that North Korea, well, that it's a guarantee for regime survival for authoritarian regimes, isn't it? I mean, that's what enabled Russia to invade Ukraine almost with impunity, at least with the knowledge that NATO wasn't going to come in on Ukraine's side, because that would lead to nuclear war. So deterrence is definitely a thing in that we were deterred from defending Ukraine in that situation in case it led to nuclear war. And that was a big part of the Biden administration's thinking in terms of how far they would allow American weapons to be used by the Ukrainians to strike back inside Russia. Isn't that right?
I don't know. I don't know what the people were thinking. I mean, that's one theory, but Putin threatened to use nuclear weapons and didn't use them. And so, do you believe that they would use nuclear weapons? Because they know that using nuclear weapons is suicide also, not just because of other countries attacking them. When I give talks about nuclear winter, I ask, how many weapons do you have to threaten to put on the capital city of your enemy to deter them from attacking you? And the answer is always one. That would be so horrific that we wouldn't want that. So I say, so how do you decide how many weapons to have? Maybe you need two in case the first one doesn't work. All the countries in the world, first of all, there's only 9 countries in the world that have nuclear weapons. So there's more than 180 countries who have decided they're better off without them. What can we learn from them? Second of all, there's only 2 countries that have huge arsenals, the United States and Russia. All the other countries have a few hundred. The US and Russia have thousands. Why do we need thousands? If you want to look at all potential targets in Russia, for example, cities over 100,000 people, there's only a couple hundred. So if you have thousands of weapons, what are you going to do? Bounce the rubble? How many do you have to use? And there is no way to defend yourself from nuclear weapons. The anti-ballistic missile systems have been tried, but they don't work. So, in fact, the ABM treaty understood that if there were huge anti-ballistic missile systems and they worked, that would threaten other countries because it means you could attack them with impunity. So that's why they agreed not to have them. But even when the U.S. tried to make them as Star Wars, so-called Star Wars, it doesn't work. It's very hard to shoot down an incoming missile. And even if you wanted to, you could put lots of decoys in the rocket too. So you'd have 100 things coming at you, not one. How do you know which one to shoot down? Way to do it is in boost phase. So when the rocket's first launching, is going slowly. If you could shoot it down then, that would be easier. But you've got to get close enough to do it, and you can't do that either. So the existence of nuclear weapons means that they can be used, and we've come very close.
And the existence of nuclear weapons, I mean, to my thinking, and I think you would agree, means that there will eventually be a nuclear war just through the laws of probability. I mean, you say we've been lucky several times. There's been near misses from the Cuban Missile Crisis to the Able Archer exercise in 1983. The fact, and also there's the sort of hair trigger alert aspect as well. I called my book 6 Minutes to Winter because the US president has literally 6 minutes, potentially, or a smaller window of 6 minutes to decide whether to retaliate to incoming missiles, which are at that point just a dot on a few blips on a radar screen. So you don't even know whether to believe it. So it's even crazier than than people might think, in that that you could literally have the destruction of civilization based on a faulty computer reading.
What if you're sitting there in a missile silo in Montana, another person, and you're given the order to actually turn the key and launch the weapons? What would you think? Why would you do it? I guess you're brainwashed to do it. Otherwise, those people wouldn't be there. They have training exercises all the time. But why would you do it? Does that mean that we're under attack and you want to get rid of the missiles before they're destroyed? That means deterrence didn't work. So what's the point of killing millions and millions of people, more people? Or it means that we're launching a first attack. Again, what's the point of doing that? And so just the idea of using nuclear weapons, I can't think of a reasonable way to actually use them that would make any sense. some countries supposedly have a theory that will just use one weapon that will shock the enemy so much that they won't retaliate. But there have been many war games played between retired army generals, between India and Pakistan and with other countries, and they give a scenario. So they come across your border, you use one weapon to stop you, what would you do? And the answer always is, well, I'm going to use another weapon against them. I can't just let them use one weapon again. And then what's the other? Go to the other room. What do you do now? And it always escalates to using the entire arsenal. There's no such thing as a limited nuclear war. In theory, perhaps, but so we started working on this in the 1980s when the U.S. and Soviet Union were the big powers. But since then, there've been a number of more countries that have nuclear weapons. India and Pakistan, for example, have fought 4 wars across their border. Unfortunately, none of them ended up being nuclear wars. So we looked at what would happen if there was a nuclear war between India and Pakistan. And the smoke from the fires that would be started by the attacks on cities and industrial areas would cool the earth so much that it would have a huge impact not on the local effects would be horrific, as we know, blast, radioactivity, fires, but the smoke would cause global cooling and it would last for years. And so we've calculated how many people would die from famine, how much it would affect global agriculture. And depending on the scenario, 1 to 2 billion people might die after a couple years once you ran out of storage.
This is with a limited nuclear war.
It's limited only by the Indian and Pakistani nuclear arsenals. I mean, that's just one story. That's just one scenario. It doesn't matter who's actually fighting the war. What matters is that the amount of smoke. And so you can think of scenarios between India and China, for example. That's why India got their nuclear weapons in the first place. They were afraid of China, and there are constant little battles on the border. They're not allowed to use guns, so they use knives and rocks and stuff. But that's just arbitrary rule. They could use nuclear weapons.
Talk us through the big one, like the big nuclear winter scenario where you have a full scale exchange between, let's say, the US and NATO versus Russia. Like how does that unfold, and what does it look like in terms of the impact on the climate then?
So first of all, I don't like the word exchange. That's sanitized jargon to make it. I think of exchange as you buy a shirt and it's the wrong size and you take it back to the store. That's an exchange. But blasting and burning and producing huge fires that kill thousands of people and produce lots of smoke and burn people and radiate them, that's not an exchange. In any case, the U.S. and Russia have a treaty, the New START Treaty, which will expire next year unless it's renewed. When Trump was president before, he refused to renew it for 5 years, which was one of the provisions. That's one of the first things that Biden did when he became president, but now it's going to expire next year. That limits both countries to about 2,000 strategic weapons. Strategic weapon, that's another jargon, means that weapons that can be used in long distance. So it's the U.S. land-based missiles, the submarine missiles, and bombs on long-range bombers. And Russia has about the same. So there's also lots of other nuclear weapons that aren't even covered by the treaty, so-called tactical nuclear weapons, which sounds like they're to be used on a battlefield, but they're these days larger than the bombs that were dropped on Hiroshima and Nagasaki. So they would do tremendous amounts of damage too on cruise missiles, for example. So if we attack Russia and they attack us, and we've calculate how much smoke would be generated, and it would be so much smoke that temperatures would get below freezing even in the summertime. That's why we call it nuclear winter. There would be freezing temperatures in the middle of continents where we grow our food, even in the summertime. And so once we used up, let's assume the places that would be destroyed, of course, would be destroyed. But let's look at the rest of the world where there wouldn't be any bombs dropped. That people would use up the food that they have. And then we did a calculation of what are the diets in each country, how much food is exported or imported. Let's assume there wouldn't be any trade after that. People would hoard their food like we hoarded toilet paper during COVID. And so a few countries which are big exporters now and don't have large populations would still be able to have enough food for the entire population if everything was the same as it is now. So let's look at places like New Zealand or Argentina or Australia. They're big food exporters. They don't have big populations. But would they have access to fertilizer? Most of them don't make their own fertilizer. Would they have access to fuel? I was just in New Zealand. They're an oil exporter, but they don't have refineries there. So they export their crude oil and have to import diesel fuel and gasoline, petrol you call it, I guess. And most of their food that they export is cows, sheep, some deer that use pasture, not they don't grow food to feed the animals very much. So, but even if they could do that, even though there'd be less pasture, there'd still be enough food. How could they transport it to people to eat it? How could they preserve it? Would there be any refrigeration? Would there be electricity? And so there's lots of other things that countries need, like medicines or high technology equipment that they don't produce locally. And then if you think immigration is a problem now, you can imagine flotillas of hungry people on their way to these places from places that don't have enough food. So how would they even prevent invasions of people from other countries in like in South America or from for case of New Zealand and Argentina. So we've had very simplistic scenarios that show those places as doing okay in the first with these very simple assumptions, but we're looking at more sophisticated assumptions about how food would be distributed. What else would you need in terms of seeds, in terms of agriculture, in terms of fertilizer, in terms of fuel for farm machinery to continue to produce as much food as you do?
Right. So the scenario really is nuclear famine, isn't it?
Yes.
Post-apocalyptic nuclear famine. And there's if this is the paper that was in Nature Food in 2022, I think,
Yeah,
which
Lily Shaw is the first author.
paper, yeah, which you were co-author on, and that has this really scary table which lists the percentage of people who cannot survive on a country by country basis. I think for the UK it's like 99% die. Similar for the US, similar for China. So for pretty much all of the Northern Hemisphere countries, they lose virtually all of their population in a full-scale nuclear winter.
That's right. It turns out the nuclear nations, which are at higher latitudes, except for India and Pakistan, would be in a lot of trouble. North Korea, China, Russia. And so now some countries say, well, we don't have nuclear weapons because we're in a treaty with countries that do have nuclear weapons. They'll use their nuclear umbrella to defend us. So NATO, UK, and the US have nuclear weapons. So France sort of has an independent nuclear arsenal, but they will they defend us, and so that's why they no I that's why they won't sign the treaty to ban nuclear weapons. In the last decade, the international campaign to abolish nuclear weapons, ICAN, along with the government of Austria and other countries in Mexico, had a campaign to educate the countries of the world about the humanitarian impacts of nuclear war. And so there's the direct horrific effects, which I already mentioned, and they had Hibakusha survivors from Japanese attacks testifying, but also these indirect effects from nuclear famine, from not being able to grow food. And I went to 2 of the 3 international conferences. My colleague Mike Mills went to the 3rd one, and ambassadors from more than 100 countries came and learned about it. Then they went to the General Assembly of the United Nations, and in 2017, they passed a treaty on the prohibition of nuclear weapons, the ban treaty. And it's been ratified by 73 countries now, and signed by 94 countries. The rest of the world learned about how they would suffer even if no bombs were dropped there. And this is their message to the countries with nuclear weapons, that we want you to get rid of your nuclear weapons. They threaten us even if you don't drop any bombs here. There's places in the world where nuclear weapons are prohibited, like, for example, the Southern Hemisphere. There aren't any in South America. There aren't any, and even in Asia, Kazakhstan was one of the first countries to sign the ban treaty because they suffered horrifically by Russia testing their nuclear weapons there. And in 2017, ICAN got the Nobel Peace Prize for warning the world about the humanitarian impacts and for getting a treaty through the United Nations.
I
They
mean,
did it.
as a scientist, do you work with ICANN and sort of advocate abolition? I mean, it's not like anyone's pro nuclear war, so I guess it's uncontroversial that you can do that and do your atmospheric studies at the same time, right?
Well, nobody's pro-nuclear war, but some people are pro-nuclear weapons. I think we should get rid of nuclear weapons, and I even got an award from Rutgers University for my global influence for doing that. And so, and I have grants, and we do the calculations here, we do the studies, write the papers. So I'm rewarded for doing that. Part of my, I'm a professor, so I have three things I'm supposed to do. I have to do teaching, research, and service. And when I document what I've done when I'm up for a promotion or for a raise, for example. Under service, I put global service. I put I'm warning the world about nuclear war, and they like that I do that. So it's feels good to be supported in that.
We all like that you do that. Well, let's say we if we don't abolish nuclear weapons, what do you think the probability of nuclear war is?
When Beatrice Finn accepted the Nobel Peace Prize in 2017, she gave an amazing speech. She said, the story of nuclear weapons will have one of two endings. It will be the end of nuclear weapons, or it will be the end of us. One of these things will happen. So we have to get rid of nuclear weapons to save us. So, as you mentioned, their existence means they can be used. People claim that they're under control and there's, but as Dan Ellsberg pointed out, the locks on them were the code was 0000. So for a long time until they changed it. And they're run by humans. Humans make mistakes. Complicated technical systems fail. It's easy to think of recently, like the Fukushima nuclear reactor or the Boeing 737 MAX, things done by complicated things made by people. Or just last time you were in a car, I'm sure you wore your seatbelt. So God forbid you have an accident that would help save you, but it wouldn't destroy the world. Anything built by humans, anything operated by humans can fail.
Yeah, and to look at the atmospheric chemistry of nuclear winter, I mean, I studied this a bit for my book as well, but it seems the mechanism is soot from urban fires, right? And
Right.
that's fortunately hasn't been large urban fires since 1945, since maybe Dresden and Hamburg and Hiroshima, of course, and maybe Tokyo, which was firebombed as well, I think in 1944.
It was March 10th, 1945, when the U.S. sent over 300 planes over Tokyo and burned it down, and more people burned to death in 24 hours that day than any other time before or since in world history. But that was the start of the American firebombing of Japan. Every 3 days after that, they sent fleets of airplanes over other cities. And when it came to the end of the summer in August, the 68th and 69th cities that were burned were Hiroshima and Nagasaki. So it wasn't, the only difference was they only needed one bomb to do it rather than a whole bunch of incendiary bombs. So it was already the U.S. policy to burn cities, and they killed over 800,000 people that summer. So I calculated what would be the climate effect from the smoke from all those fires, and it was hard to do because we didn't have a lot of data on the smoke. We didn't know whether the fires all produced firestorms that pumped the smoke up into the stratosphere. But the estimate was it would cool the Earth by a couple tenths of a degree Celsius. And then we looked at the data, which also weren't great. And there's a lot of chaos, a lot of natural variability in the climate system. And so it could have gotten cold. It was a little bit colder, for a couple of years, but it could have gotten cold just by chance. So that wasn't enough smoke to cause global climate change. But in San Francisco in 1906, there was an earthquake, and the earthquake produced a fire that raged for 3 days. And Jack London wrote an article about it. He described it that the east, west, north, and south wind was pouring in upon the doomed city. The rising air made an enormous suck. Thus did the fire of itself burn a colossal chimney through the atmosphere. So that's a perfect description of a pyrocumulonimbus, of a firestorm that pumped the smoke up into the stratosphere. So, but you're right, we're lucky we don't have very many examples of that. We can't do the experiment in the real world. So we're trying to calculate how much smoke there would be from cities. We use data from the cities that you mentioned that burned in World War II, but that's the biggest unknown. How much smoke would there be given a bomb of a certain size dropped on a particular city? And so we have a team of people at San Jose State University that's working on that now, trying to calculate. We have high resolution, detailed models that will study forest fires, but nobody's ever done it for a city. So, well, we're sort of doing new work to try and figure that out. That's the biggest unknown. But given a certain amount of smoke, the climate response is pretty well known.
Right. But I mean, forest fires also produce these big pyrocumulonimbus clouds, right? And they then put soot above the weather-bearing troposphere into the stratosphere, and that's where these particles can persist for a long time and cool the climate. Is that right?
Yeah, there were a couple examples. In 2017, there was a big forest fire in British Columbia in Western Canada, and that put smoke up into the stratosphere. And then the sun heated it, and it rose up, and we observed that with satellites, and then we used the same models, the same climate model calculations that we use for nuclear winter to model that smoke. And both of the model and the observation showed the smoke rose by 10 kilometers because it's lofted. It's heated and lofted. That makes it last longer, and it blew around the world. And then, unfortunately, a couple of years later in Australia, they were much bigger fires that burned, and that put smoke in the stratosphere, which then was heated by the sun, lofted 20 kilometers, 12 miles farther up into the stratosphere, and that lasted for a long time. And so we have those examples. But if cities burned, there'd be much, much more smoke. I don't know if you've seen pictures of recent fires, like in California. You look at what's left. The house is gone, but the trees are still there. It's harder to burn trees because they're thick, and But uh, I don't know if you're old enough to remember the movie The Graduate.
Nope, sorry.
You ever seen the movie The Graduate?
No, never seen it.
It's a great movie with Dustin.
Producer Rob says he's put his hand up. He's seen it, but how long ago is this?
I don't know, 1970s maybe. Dustin Hoffman plays young Dustin Hoffman plays a guy who's going to meet this girl in Berkeley, and the uncle pulls him aside. His name is Ben. Ben, I've got one word for you about your future: plastics. And it's a great line for many reasons, but the production of plastic since then is more than doubled, or a factor of 10. So there's so much more flammable material inside of houses, inside of buildings, that it doesn't have to be the structure of the building, but in fact, if you give a fire alarm in your building, in your house, you better get out of there quickly, because you've got a lot more flammable stuff in there than you did when you were younger, when things were made of more natural things. And so that the amount of smoke would be a lot. And so we're trying to calculate how much there would be.
Is it analogous to volcanic eruptions? I mean, like Mount Pinatubo in, when was it, 1991, famously cooled the planet down by half a degree or so. I mean, was that a mini nuclear winter, or is the mechanism a bit different?
It's similar, but there's one difference. Volcanic eruptions emit sulfur dioxide gas, SO2, which reacts with water to form sulfuric acid droplets. And those are like clear droplets. And so the sky looks white, and it reflects sunlight and cools the earth. And for a year or two, the observation showed, yes, the global average temperature was about a half a degree colder. In the middle of continents, it was several degrees colder that summer. But the aerosol, the particles, the droplets that are formed by volcanic eruptions are not black. They don't absorb very much sunlight. And so the mechanism I just described, where the black soot absorbs sunlight and rises up to the top of the stratosphere and lasts for five years or more, wouldn't happen then. So the lifetime of volcanic aerosols is, we could talk about the E-folding lifetime, the time it takes for it to decay to about a third, 1 over E. So that's about a year. So after a volcanic eruption, about a year later, only a third of the stuff is left. And a year after that, only a ninth of it's left. But the lifetime of soot particles is 5 to 7 years. And so it would last for much longer. And the climate response would last it would be 5 years of nuclear winter, of low temperatures before the temperature slowly started to rise again.
In fact, I mean, there are geological parallels as well, right? Perhaps the asteroid that ended the dinosaurs, 66 million years ago. I mean, I looked into this a bit, and it probably was fully dark for a longish period of time, and presumably the temperatures went down to, really sub-zero and across most of the planet. I mean, have you looked into that as a sort of analogous example as well?
Yes, we have. In fact, Brian Toon, who I work with, and I have a book coming out from Oxford University Press in June, Earth in Flames, and we talk about what happened to the dinosaurs and how we can prevent the same fate. Now, the asteroid that killed the dinosaurs, it's actually a bit more complicated than that. First of all, they burned it, they were roasted to death before it got cold, because the asteroid smashed into near what's Chicxulub, Mexico now, made a crater 180 kilometers across, and the energy of it hitting, it was 10 times faster than the fastest bullet, vaporized the rock in the asteroid and also the rock that it hit. And that rock vapor went up and covered the world, and then it gradually settled down. And as it settled down, it coagulated into small droplets, like the size of grains of sand, of rock. And then as it came to the atmosphere, it got heated by friction. And it was like the whole world was like in a broiler. And so it was just burned everything on the surface of the earth, including all the dinosaurs, but also all the vegetation. And then that smoke from those fires went up in the atmosphere and behaved as we were discussing. It absorbed sunlight, prevented it from getting to the ground, and made it very cold for a long period of time. And that had a huge impact on the ocean biosphere too, because they needed light. And so we know that because you can find a layer in rocks around the world that has iridium in it. Iridium is a very rare mineral on Earth, but it was in the asteroid. And so you can tell that's the layer that was that the asteroid produced. And below that, you find dinosaur bones, and above that, you don't find any. So it's clear that dinosaurs ended. But in that layer also, there are these microspherules, these little grains of sand, like pieces of rock. And there's also smoke from all the fires. And so we find all three of those things in this layer. And if you go closer to Mexico, you also find shocked quartz. You find pieces of rock that were just shocked and from that blast, and they were bigger pieces, and they fell out closer to where the impact was. But these other things I mentioned were spread around the whole world, and so you find them everywhere. So it's the same mechanism that after the asteroid hit that killed many species became extinct because of that.
So they were broiled and then frozen. It's pretty difficult to survive that, I imagine, unless you're underground or hibernating, or a seed or a rhizome or something like that. So
yeah,
it's hardly surprising, I guess.
There were mammals that were able to do that, and so that they took over the world. And there were some dinosaurs that were able to, some flying dinosaurs that were able to get into holes and do that too. And we call those birds now. So you want to cook it. If you want to see what would happen after an asteroid impact, you just take a piece of chicken, put it in a broiler, and you'll see.
Right. It's a funny thing, but when you talk to people about nuclear winter, they often respond that this was something from the 1980s, and also and consider that it got debunked at some point. I'm not sure where this idea got around that nuclear winter had been debunked, but sure, it doesn't sound like it from your work. So what was going on there?
The theory of nuclear winter is an existential threat to the nuclear weapons industry and to some parts, careers of people in companies that build rockets, for example, and careers in the military of generals that are in charge of these weapons. And so there was a big pushback from the military industrial complex, and they sent out people who claimed to be scientists who said, oh, there wouldn't be very much smoke. In fact, it's still happening today. There's the U.S. National Academy of Sciences is doing a report on the environmental impacts of nuclear war. And it's been going on for 2 years now. I hope the final report's been written and sent out for review, so I hope it will be published this summer. And people from the Los Alamos lab, where they build nuclear weapons, claimed that there wouldn't be very much smoke, that buildings now are made of concrete or steel. They did a model which had fundamental deficiencies in it that couldn't get the smoke up to the stratosphere, but they didn't allow water vapor in it. So the energy of convection is water vapor condenses and forms clouds. And so there are several mechanisms in their model that would prevent the smoke from going. And they claim still that, oh, there won't be very much smoke. There'll be rubble, and so the rubble will stop the fires from burning. But that's only a small area where there would be that rubble. The fires would be much larger. And so I'm looking forward to seeing what the committee says, because Brian Toon and I testified at their first hearing 2 years ago now. And what
you're not a reviewer on the panel's report, on the National Academy of Sciences report?
Nope. Because I'm one of the people they're reviewing. So
right. That would be a conflict of interest, I guess.
I know, but I know people on the committee, and they're very good scientists, and so I think that they'll do a good job of evaluating the claims and the evidence from different people. But I'm sure the report will say we need more work. The problem is one of the things we told them was we need more work, but the U.S. government won't fund this work. Normally, we get funded by National Science Foundation, by NASA to do our science, but none of them will give us any money to do this. The only way we were able to do it was philanthropic funds have given us money, the Open Philanthropy Project, and now more recently the Future of Life Institute. But without that money, we couldn't do it, because even the Defense Department won't give us any funds. You'd think they'd want to know what would happen after a nuclear war. Or
maybe President Trump will kick in some funds. I mean, I'm only partly joking, given his massive swinging cuts to science, but he's actually said some quite interesting things on nuclear weapons. Right? He talks about a third world war. He does say that he's worried about weapons. He's not sort of let's go in there. What's your reading of the administration on this issue?
Trump can't help lying when he opens his mouth. That's my first reaction. Would that it would be true. Actions speak louder than words. Let's see him. When he first won the first election, I was in shock like everybody else. So I wrote an open letter to him, and I said, "Dear President-elect Trump, you now will have access to the U.S. nuclear arsenal. If it's ever used, it would produce nuclear winter. But what you could do is you could get rid of the weapons, or you could at least get rid of the land-based missiles, which are the most unstable part of it. And if you do that, they'll give you a Nobel Peace Prize, and it's gold and shiny. Wouldn't you want one of those?" But I guess he doesn't read, so he didn't do it. So, and then I sent it to him again this time when he got elected. So let's see. He has an opportunity, and then to sign a new treaty with Russia, because the New START treaty is going to end next year. But he could take unilateral action. It's the Republican presidents over history in the United States that have reduced our arsenal much more than the Democratic presidents, because it's harder to accuse them of being weak on communism or weak on Russia. George H.W. Bush drastically reduced our arsenal as the Soviet Union was falling apart, and then the Russians followed suit. Didn't need a treaty for that. So all Trump has to do is order stop the spending on the Sentinel missile, which is this new missile that they're building to replace the current Minuteman missiles, which are sitting in silos out west. So they're going to build these new missiles and bury them and not be able to use them, and cost $1 trillion, and they're many years behind schedule and tremendously over budget. And there's rules. If something goes over budget by a certain amount, you've got to review it, but they're ignoring those rules. And so it would be easy to take simple actions like that, like declare that we will have a no first use policy. But instead, Trump says all options are on the table, even with respect to Greenland. All options are on the table. When you say all options are on the table, that's threatening to use nuclear weapons. That's what he says. So he might say that he doesn't like nuclear weapons, but he also says stuff like that. So if he would just declare a no first use policy, or take these weapons off hair trigger alert. I mean, if they're being attacked, then one way that they refer to these missiles is a sponge layer. The Russians know where they are, so you can count on Russia wasting a lot of weapons on those targets rather than targeting cities. But of course, they have so many weapons, they can do both if they want to. So what if they're being attacked? Why do you even have to use them? It's too late then. So what's the point of, so if we ever want to use violence to solve our problems, there's plenty of nuclear weapons on submarines, which are invulnerable, and you can use those, and you don't have to do it instantly. We have plenty of nuclear weapons that can be put on these stealth bombers that can go drop bombs places, and we can do that in a more deliberate manner if we ever want to do that. We don't need the land-based missiles. So he could get rid of the land-based missiles, although it's a lot of money. Certain companies that are building it. It's a lot of military careers in charge of it. So that's what we few professors, which the government won't fund, are fighting against. So I'm glad that this is an opportunity to tell people about this. But nuclear winter was never debunked. There was never nobody ever showed that if you put that much smoke in the atmosphere, you wouldn't get the cooling. In fact, the Lawrence Livermore National Laboratory, one of the other nuclear weapons lab in the U.S., did a study of the India-Pakistan case, and they said if you put the same amount of smoke up that we did, you would definitely get the same amount of cooling. So the theory of blocking out the sun, it gets cold, is pretty well established. I mean, it happens every night. It happens every winter. There's less energy and it gets colder. So that's pretty simple physics.
Yeah, we had a solar eclipse at the weekend, and it got colder. I mean, it was very noticeable in the temperature, and that was only like a fifth of the sun that was blocked off. But I mean, you've been listened to before by presidents. I mean, am I right that nuclear winter theory back in the 80s did have an impact on both Reagan and Gorbachev in terms of
yeah. At the same time, the American team, Turco, Toon, Ackerman, Pollack, and Sagan were working. So in 1982, I went to the American Geophysical Union meeting. That's the biggest meeting of geoscientists held every year. And there was a talk on the climatic effects of nuclear war. And I went to the talk, and there's a little sign on the door that said, "This talk's been canceled." It turns out several of them worked for NASA, for the NASA Ames Research Lab. And the center director said, "You can't use the word nuclear war in your work. If Reagan finds out about that, we'll lose our funding. We don't do nuclear war. We're NASA." So they went back to the drawing board, and what are we going to call it? And Rich Turco thought up nuclear winter, the cause and effect in 2 words. It was brilliant branding. But they also publicized it, and a Russian team, Alexandrov and Stenchikov, took that idea and used a climate model to calculate what would happen. And they got the same thing. They also got nuclear winter, and their paper was published at the same time as this American TAPS paper. And so both Reagan and Gorbachev heard from their scientists and the scientists from the other side with the same answer. And they both said that message helped them decide to end the nuclear arms race.
Amazing. And you also met Fidel Castro a decade or so later, is that right? Were you trying to persuade him of something, or what was that about?
I had a student, Juan Carlos Antuña from Cuba, who got a master's degree with me at University of Maryland. And when I came to Rutgers, got a PhD, went back to work in Cuba. One day I got an email from him. He said, "The Cubans want you to come here and give a talk about climate change." And I said, "I don't understand. What's this about?" Because I'd been there before, but for meetings. And he found a website the next day. He showed it to me, and there was Fidel Castro with Tomas Gutierrez, the head of the Cuban Weather Service, looking at a report about nuclear winter. Fidel had fallen down and broken his leg, and also apparently got cancer, and gave up control of the government to his brother Raul. But then he got better, and in his spare time, somehow he discovered my work. And so I said, "Okay." And so they said, "Well, we'll pay for your trip, so you can go to the Cuban mission." Cuban didn't have an embassy, but they had a mission to the United Nations. So I live in New Jersey. I went to New York City. I went to the Cuban mission. "We want to pay for your trip. How much is it going to cost?" I said, "Well, I got a ticket. I have to go to Canada, and then I can fly directly to Havana." And so the one-night hotel in Canada and the flight, $1,400. And they said, "Okay, here's $1,400 in cash." And this is before I said, "Can you give me a check?" "No, it's easier for us to give you cash." So that was even before I went. So I thought, this is kind of special. This is quite different. And I walked around New York City with a lot of money in my pocket. Fortunately, I got home with it. And I went there. I got off the plane, And Tomas was standing there waiting for me and said, come with me. And we went to this air-conditioned room. Give me your passport. We'll give you your visa. They took me to the Hotel Nacional, this beautiful Art Deco hotel along the water that was built by American gangsters in the 1930s. There was 5 people standing there waiting for me, including the director of the hotel. Welcome, come with me. And they took me up to the VIP floor, and I got a suite at the end of the floor. So I had 2 bedrooms and a living room, 2 bathrooms just for me. This is kind of strange. And then Tomas said, let's go have lunch. Would you like a mojito? I said, no, I don't think so. I have to give a talk. And we were in this very nice restaurant there, and his cell phone rang, which was new because they didn't have cell phones before in Cuba. Sí, momentito. Would you mind if the comandante comes to your talk? No, because they had a little conference room there, the former casino, where we were going to have a little conference on climate change. But so they took me to this conference center out the edge of town where there were 150 people in the room. All the scientists from Cuba were asked to come, and so Fidel was there, and I was introduced to him and give your talk, and he says, "Do you mind if we record this?" No. So I gave my talk, and then I talked to him afterwards, and he gave me pictures that he autographed, and my talk was put on nationwide television the next day during prime time, and they only have 2 channels. And so I got a private tour of Havana, and we went to a hotel, and I said, let me see if I'm on TV. And we went up to the TV there, and there was a Julia Roberts movie from a bootleg DVD. And I said, can you change the channel? And there I was giving a lecture. So that taught me you have to connect with people's emotions, not with their intellect. You've got to have a movie where there's this beautiful scientist from St. Petersburg who falls in love with a handsome scientist from Oak Ridge. Meanwhile, along the border between India and Pakistan and Kashmir, there's a skirmish going on, and they save the world from nuclear war. But I haven't been able to get that movie made. So
amazingly, you've got a script half written in your head by the sound of it. You didn't complain to Fidel about him having nearly caused the nuclear war in 1962 and the Cuban Missile Crisis?
No, but that was the first time I met him, and a week later, he and his weekly blog. So we have to get rid of all the nuclear weapons, or we'll have nuclear winter. So he basically repeated what I'd said, and the newspaper, the Granma, the next day had a 4-page spread about my talk on the front page. So he really publicized it and agreed to it. And then a year later, there was a science delegation that went to Cuba, and Fidel's son, Fidelito, who's my age, who's a nuclear physicist, he's the president's science advisor, met me. He said, let's come to lunch. And I said, oh, hi, I didn't know I was going to get to meet you or your father when I was here last time. I didn't have any presents for you, but now I brought you some Rutgers baseball caps because baseball is a big sport there. And he said, which one is for me? Because I had a blue one and a black one. He said, I don't care. Keep one and give the other one to your father. He said, well, we'll let him decide. I said, what? He said, yeah, we're going to go see him after lunch. So we had this big, nice lunch, and we went. I sat across the table from him for more than 3 hours, Fidel, who told his whole life story, including the whole story of the Cuban Missile Crisis and how they distributed all the planes to different airports so they couldn't bomb one at the same time, and how lucky they were that Kennedy was the president, because if Nixon had been the president, they would have invaded, and the Americans would have lost, because we know how to fight guerrilla war, but it would have been much worse for both countries if that had happened. And so he told his whole story in 3 hours, and it was all videotaped. So that was pretty surrealistic too.
Amazing. I mean, it was a close-run thing, the Cuban Missile Crisis. Is it Black Saturday when the Soviet submarine was really seconds away from firing a nuclear-tipped torpedo, right? So
they were dropping these sort of practice depth charges on the submarines to get them to surface, and they were diesel submarines, so they couldn't stay underwater that long. And they had a nuclear torpedo that nobody knew about, and 2 of the 3 commanders said, let's launch it. But Vasily Arkhipov, who was an admiral, happened to be on that ship, said, no, don't launch it. So he's known as the man who's saved the world. The same day, a U-2 spy plane was shot down over Cuba. That was when we came very close. When Juan Carlos came to Maryland to be my student, I took him to the Air and Space Museum, and in Washington, it's part of the Smithsonian, there's a room which has remote sensing, and hanging from the ceiling is an ER-2 airplane, which is a civilian version of the U-2 spy plane, because it can fly up to 20 kilometers and measure the stratosphere. And he said, I've seen one of those before. I said, what? He said, well, when that plane was shot down over Havana, it ended up crashing near Santiago, and they took its engine, and it's on display in this square in central Havana as sort of a war prize. And they have a couple of the Russian guns that they used to shoot it down. So he'd seen that before.
Wow. Well. Segue here. Planes that fly in the stratosphere could also release particles which could cool the planet and reverse global warming to whatever extent is decided. And so geoengineering, solar radiation management, whatever we want to call it, that's something you've studied as well, right? So what the climatic effects of that would be, because it's pretty similar mechanism to the nuclear winter issue, right? What's your take on that?
First of all, I like to call it climate intervention, because it's if you call it engineering, it makes it sound like you know what you're doing. But first of all, it can't be done because the technology doesn't exist. There are some airplanes, research planes or military planes that can get into the lower stratosphere, but they're small planes. They can't carry anything with them. And so you need to spray a lot of SO2 gas or other particles in, and you need bigger planes that could do that, and they don't exist. So people are on the drawing boards, have invented certain planes, but they never built them. And so we want to do it today. We couldn't. You can fly into the stratosphere, which is, as you said, it's the area. We live in the troposphere where there's rain and weather that can wash particles out. The lifetime is about a week for particles in the stratosphere, but these sulfur particles is about a year. So it's 50 times more effective if you can get the pollution up into the stratosphere. If you go to high latitudes where the tropopause is lower, where the stratosphere is easier to get to, you can fly planes up into there. In fact, every time you fly between the U.S. and Europe, especially in the wintertime, you fly through the lower stratosphere. But
so couldn't put particles in that.
You could take a tanker plane that's used like to refuel airplanes and modify it perhaps to spray stuff. But if you put it at higher latitudes, it won't be very effective at cooling the Earth, because the circulation of the stratosphere is upward in the tropics and poleward and downward, and so it would only last for a few months, not for a year, and it wouldn't cool the warm part of the Earth. So that wouldn't be nearly as effective. So okay, anyway, there was a meeting at NASA Ames, the same place where Toon and Ackerman and Pollock used to work, in 2006, where they were discussing geoengineering, climate intervention, and there were scientists and engineers getting up saying, "Oh, this is really cool. We could do this. We could do that. We could control the Earth's weather." And I started writing down reasons why it might not be such a good idea, and I got up to 20 reasons, and I published that. They had a lot of hubris. They thought that they didn't understand natural variability. So, for example, Lowell Wood, who was Edward Teller's right-hand man in making the H-bomb, was there. And he said, well, we're going to manufacture particles. We're going to engineer them so they don't destroy ozone. He didn't say how he would do that. And we'll put them just in the right places so that we will control the regional climate. And I said, Lowell, there's a problem with what you want to do. He said, yeah, what is it? I said, it's called wind. You can't just put stuff in the stratosphere and have it stay there. It blows around. Oh, we'll solve that problem. So I wrote down a bunch of reasons why it might not be such a good idea. And now I have a list that's even longer than that. So I think governance would be the biggest problem. If you could do it, how do you set the planetary thermostat? Who decides? Countries in the tropics would like it cooler. Countries at high latitudes wouldn't mind it being a little bit warmer. And we're looking at impacts on agriculture, again, because it would get not only sea level rise, but also agriculture. It would be too hot in the tropics, so they would like it a little bit cooler, but higher latitudes could grow more food if it was a little bit warmer. How do you do that? Because you can't control one part of the world, and there's no boundaries in the atmosphere. At least we haven't figured out how to do that yet. And so, we have a summer monsoon every year where the land heats up over Asia and the ocean doesn't warm up as much. And so the temperature difference produces a pressure difference, and winds come in and produce a lot of rain in the summertime over India, China. If you put particles in the atmosphere to cool the Earth, you would cool the land more than the ocean. And so this temperature difference wouldn't be as large and the summer monsoon would be weaker. We actually observed that after the Pinatubo eruption in 1992. You mentioned the eruption in 1991. There was a much less rain over India that summer because the monsoon was weaker. And so do you want to do something that would affect the food supply of a couple billion people? And now it's 3 billion, India plus China, plus lots of other people. So there's regional differences. You can't control temperature and precipitation at the same time. You destroy ozone. Do you want to not have any more blue sky? Do you want to not be able to see the Milky Way if you ever get out of cities and go out in places where it's dark and clean air? Do you want to mess up remote sensing from satellites or astronomy? And what if something goes wrong? I mean, as I mentioned before, anything made or by humans or operated by humans can fail. Would you trust the whole world to some very complicated system?
Well, our producer Rob is in favour of solar geoengineering, so he's waving like. Are you persuaded, Rob? No, I think all 22 of your reasons will be necessary for that one. But just to finish off here, Alan, because we've taken a lot of your time, and I'm really grateful. People like I'm as you are. I'm an advocate for the total abolition of nuclear weapons. I don't think anything else makes sense. As soon as any actor has one, you need one to deter them, and then you get escalation, and you get an arms race, and ultimately you get nuclear war. But people always respond to say, well, it's just, frankly, it's completely impossible. It's inconceivable that the nuclear powers would give up their nuclear weapons. So is there any kind of counter argument you've found that people that shows that it is realistic that we can get to a world free of nuclear weapons eventually?
Well, first of all, most of the world is free of nuclear weapons. They don't have any at all. So there's only 9 countries that have them. Anything created by humans can be taken apart. We had 70,000 nuclear weapons in the 1980s, and then the arms race ended. The number's been going down and down and down. There's about 12,000 in the world now. What did we do with those? We took them apart. In fact, the Nunn-Lugar Act gave money to fund Russian engineers and scientists to dismantle their bombs and send the radioactive material to the United States to be diluted and used as fuel for nuclear power plants. And so we know how to take them apart. We know what to do with them. And why do countries like the UK have 200 weapons and not 2,000? They decided 200 was enough. So the first thing we could do was the US and Russia could get down to the same levels that all the other nuclear nations have, a few hundred rather than a few thousand. So that's the first step. That would make the world safer. And then if you kept enough to deter an attack, say 10, but you didn't have enough to produce nuclear winter, that would make the world safer too. It doesn't have to go all the way to zero that quickly. Just like with global warming, you don't have to get rid of all fossil fuels. Nobody's figured out how to fly an airplane halfway across the world without jet fuel because the energy density is so high that you can take the fuel with you. So, but you have to reduce. Other things can be electrified pretty easily, like cars, for example. So you can take it in steps, and there's a group called Global Zero that's figured out different steps. Now, the treaty to ban nuclear weapons has been signed by most of the countries of the world, and that commits you to not only not have them, but not use them, not threaten to use them, and to work to help the people that were damaged terribly by the production, testing, and production of nuclear weapons in the past. So there are paths to take. It just takes political will. It doesn't take rocket science to do that.
Well, I hope that our books can help. And your book's out in June, did you say?
Yes.
And what was the title? Remind us.
Earth in Flames.
Earth in Flames. Wow. I'm so much looking forward to that. Also to the National Academy of Sciences report, which I'd forgotten about. So that I mean, all of this will hopefully up the ante and help put this a bit more on the agenda and maybe give some more impetus to arms control talks.
Also, the United Nations just voted in December to have an international study of the impacts of nuclear weapons on agriculture, but on trade, on infrastructure, on everything. And they're putting together a team of 22 people, 22 experts to write this report. But that won't be done for another couple years. So I nominated myself. I'll see if they take me or not. So
Right. Well, good luck with that. And Well, let's hope let's hope some people can hear this and take note, because a world with nuclear weapons will not survive indefinitely. I think we can both agree on that.
Let me just mention, do you know about the Drake equation?
Yes. I talk a bit about that, but no, tell us what your take is on that finally.
Well, the question is there life on other planets? We don't have any evidence of it. Why? There's so many, in theory tells us there's so many planets, and the probability of having intelligent life is high, so why haven't we heard from them? And one idea that Carl Sagan had was, well, once you develop a certain level of technology, you end up destroying yourself pretty quickly, and so you don't have very much time to broadcast a signal. Or another theory, of course, is they went to cable rather than radio. But is that why? Is there some way we can avoid their fate? That's what I'm trying to educate people about.
Well, so if we have a nuclear war, the silver lining will be that we've solved the Drake equation for the rest of the universe, which at least there'll be some cold comfort there. But anyway, Alan, thanks again. Thanks so much for your time. I hope we can stay in touch. And please, everyone, if you're listening in June, do go and buy the book. So for now, thanks very much, Alan.
Thank you very much.
Thanks so much for listening to Saving the World from Bad Ideas, a We Planet podcast. We Planet's a movement of citizens and scientists dedicated to defending the science and solutions we need to save the world. Please do subscribe and share a nice review. It helps us spread the message. We'd also love to hear your feedback and suggestions at our email, podcast@weplanet.org. Please also join our podcast mailing list and we'll let you know when a new episode drops. Just go to savingtheworldfrombadideas.org or weplanet.org/podcast right now. See you next time.